Hello friends, today in this lecture we are going to learn how we are going to test the third assumption of regression, that is residuals should be normally distributed. So I've already discussed that what do you mean by residuals and what are the different tests so that we can check whether our residuals are normally distributed or not. So before starting, let me write that what are the various tests by which I can check whether my residuals are normally distributed or not. So first is I can plot the histogram, and with the help of histogram also I can check whether my residuals are normally distributed or not. Second method is to plot QQ plot. With the help of QQ plot also I can check whether my residuals are normally distributed or not. Third way is to check by Shapiro-Wilk method. So I can write Shapiro-Wilk test. This is the third way. Fourth method to check the normality, that means whether my residuals are normally distributed or not, that is Komolgorov-Smirnov test. Next method is Darlingtest. And next method is by Jarque-Bera test. So these are the 6 methods by which we can test whether my residuals are normally distributed or not. We have already created the model in our previous lecture, so I am using the same data set. That means my variables are FDI, export, imports, inflation rate and USD. My dependent variable is inflation rate and my independent variables are export, imports and USD INR. I want to see whether these independent variables, that means USD INR, exports and imports, have some impact on inflation rate or not. So my regression model is, I can just make it again. So my regression model is model 3 is equals to LM, my inflation rate, now tilde sign, your exports plus imports plus USD INR, and then enter. So model 3 is equals to LM, inflation rate, tilde sign, exports plus imports plus USD INR. So your model is created, and I have also stored the residuals in the vector residuals. Model 3 is equals to residuals and name of the model. Now first of all, let us check whether my third assumption, that means residuals are normally distributed or not. So for that, the first way that we have learned is to plot the histogram. But now before checking all this test, now the first question that comes into my mind, that whether the checking of residuals to be normally distributed is important. Whether we should give any weightage to this assumption that the residuals are normally distributed. So yes, the answer is yes, we should give the weightage to find out whether these residuals are normally distributed or not. Now let me explain to you with the help of an example. Now let's take an example. I can say that you want to try to analyze the factors which are useful to predict the stock price, or you can say some sale of a product. And you took some 4 independent variables, and once you have created the model says that on the basis of 5% level of significance, the variables that you have selected have affected the stock price or the sale of a product. Now the model is saying that all the 4 variables that you have taken are significantly impacting your dependent variable. But when we check that whether the residuals are normally distributed or not, and we find that the residuals are not normally distributed, so we can say that all the error terms, that is also known as residuals, if the distribution of error is significantly deviate from the mean 0, that means in the previous lecture I have told you that the residual should be equals to 0 and the mean is not 0 and plus the normal distribution, there is not a normal distribution. Then the factors that you are taking into consideration, that means all the independent factors that you choose to be significant, may not be actually significant to explain the independent variable. Now let's check with the example that we are doing. So let me write summary model 3. Now from this we are seeing that all the independent variables that I have taken, export, imports and USD INR, they all are significant because the value of P is less than 5% level of significance. Now by looking at this output, I can say that these 3 variables, export, import and USD INR, are significantly impacting my dependent variable, that is inflation rate. But do you think that these 3 variables are actually significantly impacting the dependent variable or not? That can be tested by checking all these assumptions. Now, if my residuals are normally distributed, then I can say that yes, whatever is the output, that these 3 variables are significantly impacting the independent variable. But if the residuals are not normally distributed, though the output is showing that these 3 variables are significantly impacting my dependent variable, that is inflation rate, but in actual these 3 variables are not significantly impacting my dependent variable, that is inflation rate. So let us check by the different methods that I have mentioned over here. So the first method is histogram. So first of all, I am going to give the command hist and we are going to see whether the residuals are normally distributed or not. So that means I am going to make a plot of residuals. So hist residuals, I have stored the residuals in the vector residuals model 3. So this is my histogram. Now you can see that this histogram is not normally distributed. There are some outliers. One variable is residuals is over here, one is over here. So if you are going to make a bell-shaped curve, it is not going to come a bell-shaped curve. So with the help of this histogram, I can say that my third assumption is violated. My residuals are not normally distributed. Now let's come to the second method, QQ plot. Now QQ plot means quantile-quantile plot. Now how can we prove with the help of QQ plot that the residuals are normally distributed? So now what the question comes into the mind is that what do you mean by QQ plot? What is the role of QQ plot? So the QQ plot compares 2 probability distribution by plotting their quantiles against each other. If these 2 distribution which we are going to compare are exactly equal, then the points on the QQ plot will perfectly lie on the straight line. That means whatever is my regression equation, on the regression equation all the residuals should lie. And if the residuals are not on the regression equation, then we can say that the residuals are not normally distributed. So for that, I'll say plot and model 3, 2. Now you can see over here, this is my regression equation, these dots, and these are my residuals. And you can see that all these residuals are not lying on this line, which shows that my residuals are not normally distributed. They are diverting from this line. So With the help of QQ-plot also I can prove that my residuals are not normally distributed. So my third assumption is also violated. I can also plot this QQ-plot with another command, that is QQ-norm, and in bracket I can write residuals model 3. Now you can see that you will get the same plot and your regression line will be straight line from this -2. So if you are going to plot this line from this -2, you can see that all the residuals are not coming or are not lying on the straight line. So QQ plot also shows me that the residuals are not normally distributed. Now the third method is by Shapiro-Wilk test. Now this Shapiro-Wilk test was first published in 1965 by Samuel Sanford Shapiro and Martin Wilk. So with the name of these two persons who invented this method, our Shapiro-Wilk test was named. So whenever we are checking the normality with the help of Shapiro-Wilk test, so my hypothesis will be, so my null hypothesis H0 will be that your residuals are normally distributed and your null hypothesis or alternative hypothesis will be that residuals are not normally distributed. So let us check whether our residuals are normally distributed or not. So to check with the help of Shapiro-Wilk test, our command will be Shapiro.test and then I am going to write residuals model 3. Now here is an output. You can see that the p-value is less than 0.05. It's 1.529 e minus 0.9. So what does it mean? That the value will be 1.592 multiplied by 10 raised to power minus 9. So that means it's a very small term. It's near about 0. So p-value is less than 0.05. That means 5% level of significance, which shows that we cannot accept our null hypothesis. So the output shows me that your residuals are not normally distributed. So my first method histogram, second method plotting the QQ plot, third method Shapiro test, all the three tests are saying that your residuals are not normally distributed. Your third assumption is violated. Now let's check with the fourth method, Anderson-Darling test. Now if you are going to check with the help of Anderson, fourth is your Komolgorov-Smirnov test. So for Komolgorov-Smirnov test, your command will be ks.test, then your residuals. Now residuals are residuals model 3, comma, in semicolon you have to write p norm. Now this output is saying p-value is again a very small value, that means near about 0. So it's less than 5% level of significance. Again my null hypothesis is not accepted. So I can say that my residuals are not normally distributed. So as we all are aware that if the p-value is less than 0.05, we are not going to accept the null hypothesis. We are saying that we are going with the alternative hypothesis. So over here the fourth method, that means Komolgorov-Smirnov test, is also saying that your residuals are not normally distributed. Now let's come to the fifth method, that is Anderson-Darling test. Now before checking this test, we need one package, that is norm test. So what I am going to do, I am going to library NOR test It is the test of normality. So you have to install this package, and once you have installed, you have to library it. Now let me check with the help of Anderson-Darlingtest. So command is ad.test and then residuals model 3, and here is your output. Now Anderson-Darlingtest is also saying that p-value is less than 0.05, hence we are not going to accept the null hypothesis, so we are going with alternative hypothesis, which is saying that residuals are not normally distributed. And the last method is Jarque-Bera test. So command will be Jarque.Bera.test and then your residuals model 3. Now the p-value is again less than 0.05, which is showing that we are not going to accept our null hypothesis. We will be going with the alternative hypothesis. Hence my residuals are not normally distributed. So all the methods, maybe the histogram, maybe the QQ plot, your Shapiro-Wilk test, your Komolgorov-Smirnov test, your Anderson-Darling test and Jarque-Bera test, all the 6 types of tests are showing that your third assumption, that residuals are normally distributed, is violated. So that means my model is not a good fit. So that's all for today's lecture. In the next lecture, we are going to study how we are going to check this fourth assumption, that there should be homoscedasticity in residuals. Now let's see whether this fourth assumption is violated or not. Thank you.